Hello, everyone. Hello,
Hey
Aaron. Good
everyone.
seeing you. Yeah.
Yeah,
Hello.
you as well as you, Mary. Yes, good to see you too.
Thank you. Thank you. Thank you. Yes. Yeah. We're back again. And I can't believe a week goes by so fast. And there's just so many exciting things are happening. So, yeah.
Right,
Yeah.
right.
Yeah. Awesome. Yeah. 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 So, today, too, welcome everybody joining us again this week, the third episode. Yeah. Time goes by fast. And we continue to talk about real time AI and Java. A lot of things have happened as this series is going on, things around us. So yeah, so today too, we prepare for you a couple things that we'll be talking about, like again with more with Java centric kind of perspective. And again, I think like we kind of talk about, right, Python is easy for a lot of folks to start coding, and I think Python also doesn't kind of it's a bit of a free flow thing. It doesn't enforce you to do things in a certain style. So I think a lot of people, right, like if you are not paying attention to compute on the computing side, how do you design a system is
Hmm.
actually easier to do. However, the backdrop, the kind of not so kind of favorable thing is that it's just not built to scale on an enterprise level. So that's when Java comes in, and we're so excited to talk about it. It may be early, but I don't think the time is really too early. I think times are kind of coming that we will see kind of the Java growing in more and more importance, taking over the machine learning. Not maybe not so much taking over. It's really coming into the main kind of spotlight too for doing machine learning things. So yeah, and I know too. We talk about like vector is like foundational now with Gen
Yep,
AI.
yep.
Vector is everywhere. We talk about it the first two episodes too. What vector is, and the thing is too, there's also vector API. I think we briefly bring it up, and today we talk about it again. Aaron and I, Aaron will be talking a bit more, going in depth about vector API, and also showing a demo too. So yeah, so let's have Aaron start, and then I'll also introduce you to some new ideas with streaming too after Aaron finishes his talk. So yeah,
All right. Well, hey, thank you, Mary.
yeah.
Um, I suppose if I was a little smarter, I would have had my screen share like staged up already, but
Oh, don't worry.
alas, I
this
do
is
not.
this is supposed to be very spontaneous. So yeah.
Let's see here. Yeah. So if I just go, oh, is it going to make me like? Okay, I'm going to do an entire screen share. I'm going to be bold here.
Sure. Go for it.
All right.
Oh, yes, there we go. Let me bring it up.
Okay, there we go. All right. So if this worked, then you're likely looking at my Eclipse IDE here, where I've kind of gone out and based on some like the articles and examples that are out there for the for the Java Vector API, and just put together a very simple example here. So we essentially vectors, with the way that we deal with them inside of like vector databases, vector APIs, etc. They come across as like arrays. So like I know that Cassandra and Astra tend to deal with like arrays of floats. Inside the Java API, you can do float or integer. In this case, I've built a couple of arrays that are just a size 8 array of various integers. The way to actually pull that into and instantiate that Java vector type, it's this int vector here, and it has a from array method. And essentially, what it takes is what's known as a species, which is really just if you want to think about maybe kind of a like a numerical or binary template that you're going to use for the storage of the vector. And in this case, it's using the 512 byte one, which I think is as big as it gets. And anyway, so then I can specify my vector next, and you can do what's called an offset. And I didn't want to use an offset, so I'll just kind of keep those at 0. But essentially what I'm doing is creating two vectors, and then we're going to use the vector API to add them together and just show the result. I mean, this will be super simple. So if I go ahead and run this, And it's thinking. Oh, are you kidding me? Of course, I get an exception when when I'm trying to show this. I'm trying to show this live here. All right, so line 23, what did it not like? Oh, you know what? How about, you know what? Let me, I think I know what I did here. I think I altered, yeah. Let me redo. There we go. Let's just go max instead of 512.
Oh,
And I wonder if that will do it.
okay.
So if you're taking anything away from this so far, it's that yes, the species is actually fairly important there. So make sure you get that right. But anyway, as you can see, you know, so I have, you know, vector 1 kind of laid out here, and then, you know, vector 2 is underneath it, and it's just basically going through and doing a excuse me, a vector dot add to you know, sum up each of the elements or lanes, as they call it, inside of the Java Vector API. So of course, you know, this, you know, you're probably saying, if you're a developer, you know, you're probably saying, hey, this is cool and all, but what would I ever use this for?
Yeah.
How about we consider maybe that we could have like city coordinates as vectors. And this is actually a quick preview into a blog post that I've been working on that's it's going to come out soon. But essentially, what this is doing is trying to use a different way, or trying to use vector search actually to solve the traveling salesman problem. You know, where the salesman has, you know, a whole bunch of cities to visit and needs to figure out the best order or most efficient order to go visit them in. You know, so if I look at the cities that we have here, and the thing is, when you're looking at Cartesian coordinates, you know, in a small geographic area, they're all going to have the same whole number, right? So what I've done here is I've actually created my vector using everything to the right of the decimal point. So you're looking at the decimal point value of you know, of this particular metropolitan area. And the idea is that I'm starting at this city named Farley, and that's the vector that I started the search by. So that's how you see I have this 100% match here. And when all the cities come back, you know, this one, Rogersville, is the closest vector-wise. And this other one, Parktown, is the furthest, and again, you know, by the approximate nearest neighbor algorithm. And you can see the similarity scores over here as well. So here's a thought. You know, what if I was working on this data set in Java, and what if I wanted to find like the mean, or like the middle, or the average type of vector? You know, in theory, it would come back and it would kind of line up with Maplewood, which ended up being, you know, kind of the middle. So that's a little exercise that we could try on this one. You know, so what if I take the you know, vectors for two of the towns? So we can say we're going to do an array. We'll say Rogersville. Oh, actually, you know what? No one needs to watch me be a terrible typist today, so I'll cheat and
copy and paste.
I'll just copy paste, right?
That's okay.
So I've created my cities again based on those vectors. Now I'll convert the vector, or the array of integers, into vectors themselves, and I'm using that species 64 for a 64-bit binary type. So essentially, that's the size that you need for a two-dimensional array of integers. And yes, I found that out kind of as I went along here as well.
Okay.
So, you know, then we'll go ahead and, you know, just kind of print out, you know, output to the screen what the values of our vectors are. We'll then go ahead and add our two vectors together, Now, when we want to take the average of two values, right? We add them together and then divide by 2. Well, wouldn't you believe it? The vector API has a division function. So I can go ahead and, oh, by the way, this little character 247, that's ASCII for the division symbol. So I don't have to use a slash or anything like that.
Cool.
So the idea is that, I'm building the sum here of our vectors, and then we're doing a vector div2 to go ahead and divide by 2, right? Okay, so if I did this right, and I have better luck than the first time I tried running this, I should be able to run this, and should think a little bit. Okay, look at this. Okay, so here is our combined vector, or the sum of both of those vectors, and then here's where we did divided by 2, gives us this 74, negative 457. So now I can go back to my my vector query in Astra, and I'll paste that in there, and then I'll also put it in the similarity cosine function. And if I did this right, Maplewood should come back as the top result. And look at that; it comes back with like nice. 6 nines worth of a match. I mean, so really, I was able to take the furthest, or the nearest vector and the furthest one, and come back with kind of a mean by doing all that processing on the Java side to arrive at that new vector to search by.
Nice.
So that's a little demo with nice. Both the vector search functionality of Cassandra AstraDB, as well as the Java API as well.
Yeah. Thank you. Yeah. So, can you explain a little bit like this? Yeah, the similarity cosine, right? What does it do? I mean, for maybe viewers are like wondering, right? What if you can explain?
Okay. So essentially, it's this it's this similarity cosine function, which is now a part of CQL, and essentially what it does is when it's comparing and looking at approximate nearest neighbors, in terms of the vector you're searching on, and then the other vectors that are present, it's giving you a score based on how similar it is. So it's like when it comes back, or I should say how close it is probably a better way to put it. So that's how, when you look at this first query up here, and I'm querying by like a starting city of Farley, that's where I get a 100% match, because that actually is the vector that I searched on. And then this one on Rogersville is the closest city, by vector search, or by vector approximation, I should say, that comes up. And the rest of them are rated or sorted in the order that of how similar they are to that original vector.
Oh, okay. So sort of like relative, essentially a measurement of their relative distance, I guess, from the main. Like you said, the search criteria. So So is that's what like ANN is, right? Essentially, the approximate nearest neighbor algorithms is pretty much is based on that. Now, what are some of the other algorithms too? I'm kind of curious. I read about, because I mean, folks, I'm new, right? New to this, so even I'm learning from Aaron. So so there's because I've been doing more streaming stuff is a different thing. But the thing is, this is also very interesting. I think I read about like KNN, right? Is that like something?
Yeah, like the K nearest neighbor. I'm not too familiar with the details on that one, other than to say that it's kind of like how you specify a limit here. So essentially, this is like the 7 nearest neighbors of whatever this vector is, and that's kind of how KNN is too. It's like you're kind of predefining ahead of time, how far away I guess you want to limit your search to.
Oh, okay. Okay, so it's just another,
and then there's there's another one, and I forget what it is now, but it's actually the one that Jonathan Ellis, who kind of built this functionality into Cassandra, and he's actually the founder of DataStax.
That's right. Yes.
He actually recommends you use, because it actually is faster, uses less resources than doing an ANN does. And
Oh,
I can't remember the name of it now. It's like dot something.
okay. Yeah.
Dot product? Is it dot product? Dot product sounds right.
Product. Yeah. I think, yeah. So it's some sort of like matrix, like map from like matrix operations, like a dot product type of
Yeah,
operations.
yeah.
Yeah,
Like
yeah.
yeah,
Okay, that makes
like
sense.
linear, like matrices and linear algebra
Matrices.
kind of
There
a thing.
is a
Yeah.
thing. Yeah, yeah, that's right. Okay, very cool. Even now, like as you said, right? Sometimes you look at all these kind of interesting formulas playing around, but how is it actually being used so we can actually see this put
Oh,
into
right.
action, like
Right.
linear algebra? Yeah, yeah. That's very cool. Thank you. Thanks,
Yeah,
Aaron.
of
Yeah.
course. Of
Yeah, yeah, yeah.
course.
So yeah, that's great. So I hope the folks you are finding this useful. Even I'm finding it very useful. I mean, like, I'm as such, right? We're all doing so many things. We're all like exchanging information every day and sharing. I think that's a great thing. I think we encourage everybody to do that too. And yeah, so okay, so yeah, so well, given we're trying to also like not take up too much time and stuff, but we like to, yeah. Well, next week too, I think we will also have another snippet of coding snippet
Oh,
and show
sure.
some
Sure.
things, yeah, too, yeah. So we will come up with the agenda when we get near the date. But okay, so right now then we're kind of thinking of what would be good to talk about too, as such, right? I mentioned that I've been mostly at DataStax. I joined, doing streaming stuff, and so folks might be wondering, oh, why is she talking about AI? Well, the thing is, like all of the stuff we're working on are all interrelated, right? And as
That's
such
right.
too, if you kind of look into streaming too, is actually it really is something that to me I always feel streaming is a technique that's actually very much like think of the plumbing in your house, like, and think of the fact that if your plumbing isn't working, then you're going to get into big trouble. So that's what it is. Streaming is complicated, but we always want to make sure streaming is doing the right thing because it really kind of get all the data moving, flowing very smoothly. So the next thing I just thought I should bring this up is that, as such, right, DataStax, we have our streaming team very knowledgeable in this space, and we're using Apache Pulsar to help with our event streaming. But the thing is that, we're aware of, so many streaming platforms out there and stuff. And so we are actually also like now working on like a streaming for Gen AI kind of feature right now.
Hmm.
So
Hmm.
at this point, right, because it's very new and our engineering team is working on it, so I cannot be sharing with you as much at this point. But we do promise you that at some point, in the very close, near future, we'll be able to bring to you this new feature that's kind of exciting because if you think of a lot of the for machine learning, or at least now for me getting into it, and it's a lot we're dealing with the activity is pre-training, training the model,
Right.
and that
Right.
takes up a lot of GPU. Doesn't really require streaming because everything can be done kind of have data there and you crunch through all your data in batch mode, so to speak. It doesn't require real time. The thing is that what really will be more exciting is the fact that after you train the model, the LLM and large language model that you're using, and that's what is being used for inference, right? To
Hmm.
really
Hmm.
derive at what you're trying to get at. Some prompts you're kind of feeding it and coming back with all the results, exciting results that we're looking for. So okay, so that's the thing, right? So the LLM, they are all pre-trained pretty much and in batch. So and the world keeps moving, data keeps being generated. So at the time when you train the model, it's kind of done overnight. So in between overnight and now you're trying to query it, then whatever data is happening, we haven't trained that yet. So there's actually, again, I'm talking high level, right, to kind of make folks understand. The real time data is what is really bringing us the most value. I think so too, because if
Right.
you're dealing with, especially if you're dealing with scenes, I'm kind of thinking as a fraud detection or some kind of things that you need really almost absolute real time, then you need to be able to take in this data that's missing in between the pre-trained and now. You want to be able to do that and feed it in to do inference, and so that's where streaming can come in, I believe, and that's what we're working on, is to provide this functionality. And as such too, right, our streaming is going to work in close kind of what you call it, like interweave together into our Astra streaming, I mean our Astra database, right? Which is that we can actually be leveraging on all of the vector search, all of these things that our very, very powerful Cassandra version of Astra doing all this stuff. But then we're actually powering, feeding in this real-time data, and that's what the streaming for Gen AI feature that we are working on. And also too, as such, right, and if folks here are familiar with message broker too, we are making use of PubSub. And so they can, at least theoretically, you can have millions of messages per second that can be pumped into your system for ingesting all of these data. You need to have it immediately being able to process it right away. So that's what we're working on. And then, I think it's really an exciting area. And also we're leveraging on Pulsar, as I mentioned too. If you're familiar with Pulsar, there's also this feature called Pulsar function, in which you take the you take the data and you transform it as the data is traveling through the pipeline. So the thing is too, we're also like leveraging on Pulsar function in order to help with this. And of course too, right now already in our Astra platform, we have Astra streaming. That's actually also a feature called CDC, right? Change data capture, in which we're actually watching data, in our Cassandra database. And then if there are any changes, then we can actually we code it so then we immediately react to it and create like Pulsar topics that actually take these messages or take the data that's been changed from the database and then process it. So this is just a bit of a preview to kind of whet all of your appetite to kind of knowing what to look for. It is complicated, but I think it will provide us with a lot of very useful functionality, and that is actually really the real-time type of capability that we can expect us to be able to do as a company too, where really have all the data in place. And of course too, we also have Cascada. Don't forget too, is that our Cascada is the time series stream processing, so that really adds to it too. The time series feature is also very kind of providing all of these time sensitive type of functionality to process streams too. So so that's my little kind of introduction and giving a bit of a hint to what is to come on our streaming side.
Those are all excellent points, Mary. The one thing that kind of sticks out for me is that is the example you brought up of like fraud detection. And the thing is that when you're analyzing data, when you're putting it through all these systems, and there's a lot, and it's a very large scale. It can take a lot of time to do that sometimes. And I don't know that you ever want to get to the point where it's like, oh, hey, we had a digital intruder 3 days ago. I mean, what can you do about it at that point? I mean, you can, there are some things you can start looking at, but it's much better if you're catching that in real time. It's much better to say, hey, there's an digital intruder now, as opposed to we had one 3 days ago.
Exactly.
That's a much different story that someone would rather be telling their CISO at the time.
Exactly. Yeah, that's right. And then also too, and while we're at it too, is that that's actually another challenge of training model, is that very often when you do the pre-training of these humongous LLM models, they require GPU, because only that type of machine with that graphical processor be able to process data in high, super, ultra high speed is the GPUs. But the thing is though, like with these real-time data, then how do we handle it, right? We need to train on the fly, essentially. So I think there are also talks about, well, sometimes these smaller data sets may not require GPU on a day-to-day kind of, streaming type of basis too. So that will be kind of interesting to find out too, and to see how to do this type of work. So anyway, So I think it's exciting times coming to us. Yeah, that's right. Yeah, so very cool. Okay. So do we have any? Well, actually, they are also talking about which too. They're with Java, right? Because I'm kind of been working with Java a lot, and in the previous 20 years, and so I'm more like closer to Java. So there are also different specifications that are essentially to targeting for machine learning type of capability. But we won't have time to go through all of them. But maybe in the next few episodes, one of these episodes or a couple episodes, I can also be bringing up some of these Java specifications, the JSRs, the specification requirements, or what you call JSR. JCP community process. There are different projects too, like Project Loom or Project Panama. All of these are really like all the capability can actually help with machine learning too in today's world. So I'll be talking about those in some future episode, and we also will probably have guests to join us too. Yeah, in the near future. So yeah,
that is the plan. We do have a guest lined up. Yep.
That's right. Yeah, exactly. So yeah, very good. Yeah, awesome. So yeah, so now before we go though, I want to share with you again, remind folks to next, or actually not next week. I kind of got the times all wrong. 23rd of August is our I Love AI event. So let me go find the where's my yeah I'm like searching for the QR code now. Oh, here we go. Sorry about that. Let me share the code again, and again is right here. I Love AI. So this is the event. I should have put down the August 23rd. Let me kind of fix that. So next time, but the thing is, we're telling everyone here, I Love AI, August 23rd. It's really about smart context, intelligent agents. And that's what DataStax can, kind of bring to you all of these wealth of information that we are, we'll have for you too. So, and as such, this is an exciting topic. I think it's just evolving so fast too. And we are here
Absolutely.
to help everybody on your journey to adopting, Gen AI, especially vector search with all of these. We are a data company that's kind of really doing all these smart kind of things that, that you can kind of come to us for. So, yeah. So, yeah, awesome. So, yeah, so I think we're all good for today. Yeah, so yeah.
I think we're all good. Yeah.
I think everybody has enough of us today. So please stay tuned. No, I'm just kidding. But I'm sure you love us. So yes, please come back, and next week we'll be here again. And so thank you so much again for having joined us, and thank you, Aaron. And we'll see you next time.
Oh, well, thank you, Mary. Yeah.
Thank you. Okay, bye.
All right, bye, everyone.
Bye. Yeah. Okay.